Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. You know, for the last year or so since my work with Blue Marble Science, I've kind of left some of the major flat Earth scholars alone. For example, Quantum Eraser and Nathan Oakley. The main reason that I did that was I had already completely destroyed their entire position, and quite frankly, I didn't want to give them the attention they so desperately need. But the other day I was on a Flat Earth Discord, and who other than Quantum Eraser showed up and began his usual nonsense about citations and personal insults, etc. Now, before I turned his volume off so I didn't have to listen to him anymore, he brought up a video I made about a year ago, this video right here, where I looked at his classic citations about gravity not being a force, and I very clearly demonstrated that Quantum Eraser's own citations disagree with him. Now, he put a response video out that I got quite the chuckle about. I didn't do anything at the time because, again, I didn't want to give him the attention he so desperately needs. But I've decided to go back and revisit it. So join me as we have a look at the citations of Quantum Eraser. So a little over a year ago, a number of science educators, including myself, Professor Dave, Soundwave Rumpus, MC Toon, etc., got together and had a quick discussion on gravity. Now, QE had a look at this and tried to make some sort of a grand debunk out of all of us. And this is the segment where he was going after me. Now, last week I put out a mirrored video that discussed why people deny science. One of the foundations of that is that until you are probably 6 to 8 years old, flat Earth makes sense to you because you only know what you observe in your own life. You don't really have the capability of doing advanced concepts or thinking in 3 dimensions. This is a very good example of that. Now, I want you to go ahead and pay attention to the way Quantum Eraser tries to attack me. He uses name calling. He makes fun of me misspeaking or mispronouncing words. And then he takes something that I said completely out of context and tries to make it into something else. Now, the latter is an example of something called an equivocation fallacy, which is basically taking somebody's argument and using a different meaning out of context to what they were discussing and trying to use that as a point for your argument to argue against their point. It's not an avocation fallacy, it's an equivocation fallacy, and that's what I said. He may have misheard me. Now, I did misspeak once in this episode where I talked about the speed of sound instead of the speed of light, which was the correct thing that I was talking about. It was quickly corrected and we just continued on. We all knew exactly what we were referring to. But watch how he tries to use the concrete ideation of using the speed of sound instead of the speed of light. And then he takes an expression that I used, which specifically was when he cites something out of a citation, 2 paragraphs later, his own citation contradicts him. And see how he tries to approach that. So let's have a listen.
My gravity is that I can calculate the trajectory of a bullet. And that works just fine in our world. And the other day I did a video on Quantum Eraser and his efforts to talk about gravity not being a force, where he cherry-picked about 6 different scientific papers. Every single one of those papers, 2 paragraphs later, said that unless an object is moving close to the speed of sound or is on the atomic level, Einsteinian gravity reverts to Newtonian gravity for all intents and purposes. So I'm very comfortable with Newton. Newton's just fine. Einstein just tells me a little bit more about why it happens. But I don't use field equations to figure out how much of a bullet drop there's going to be at 600 yards. I use Newton. And guess what? I can hit a 4-inch rock at 600 yards. So that's all I have to say about it.
Now, just so that this is absolutely clear to everybody listening to this, let's bring in two special guests, Blue Marble Science and the Rumpus. Have a listen to what they say and compare it to what I said.
So in the case of being on the Earth where the gravity is not very strong, you're not in a black hole, you're not moving at the speed of light, then the general relativity there, the equations in Einstein's field equations then become, in the limit, what's called the Newtonian limit, become Newton's equations, because all those other terms go to zero, finished.
QE doesn't waste any time diving head first into a mud puddle, now does he? You know, QE Rumpus was absolutely correct. As a rule of thumb, there are 3 relevant limits that tell you when Newtonian physics is no longer applicable. Let me go over these for you. Number 1, if the ratio of V to C, where V is the characteristic speed of your system and C is the speed of light, is no longer close to 0, you need special relativity. Number 2, if the ratio of the product of the gravitational constant and the mass divided by the product of the speed of light squared times the distance involved is no longer close to 0, you need general relativity. And finally, if the ratio of the Planck constant to the product of momentum and the distance involved is no longer close to 0, you need quantum mechanics. Under any other circumstances, with very few exceptions, no one would ever use Einstein's field equations to analyze something like Cavendish. In fact, Einstein would be laughing his ass off at you right now for the mere suggestion of doing that.
Now that we have that out of the way, let's go over and see QE's response and his approach to arguing this point.
So, Bobby, this is going to be fun. The other day I did a video on quantum eraser, in his efforts to talk about gravity not being a force, where he cherry-picked about 6 different scientific papers. This is 6 erroneous, ipsy-dixit, baseless, bare assertion fallacies. He didn't support any of this, and he doesn't even know what cherry-pick means. None of these knuckleheads know. We're going to go through them, though. Number 2, every single one of those papers, 2 paragraphs later, said that unless an object is moving close to the speed of sound, or as on the atomic level, Einsteinian gravity reverts to Newtonian gravity for all intents and purposes. So number 1, this is incoherent gibberish. The conclusion doesn't follow from its premise to begin with. So it's a non sequitur. But we're going to hold Bobby's feet to the fire here. So B, 11 erroneous, baseless, bare assertion fallacies. We're going to take a look. So everyone knows this one. This is George Musser, right, from Scientific American. And let's pull out a keyword here so we'll go through this quite quickly. So copy, we're going to go here. We're going to go into each of these and see if his claims hold true. So let's go find, let's go, okay, snap.
Now, I want to point out Quantum Eraser's research method. Now, I accused him of cherry picking. Now, here's what he did. He actually put a specific keyword into a search box on the article so that he could go directly to a phrase or a search word that he's using specifically to support his premise. He's not actually reading the paper for context. He's looking for a very specific phrase or sentence that he can say, oh, well, this guy agrees with me. The earth is flat, or gravity doesn't exist, or gravity is not a force. So let's see how he handles that.
Okay, snap. Okay, here's the citation that I took from this paper. Einstein, general relativity, snap the wand in 2, right? Showing that space-time, not an invisible force, right? So he said 2 paragraphs. So 1, 2. We're going to highlight this. We're looking for subatomic and atomic particles, the speed of sound, and Einstein reverting to Newton. So I'm heading through here. Nothing on Newton. Nothing on subatomic particles or the speed of sound. So there's nothing there.
You know, I really don't care for literalists in science for the simple reason that they concentrate on the definition of words and isolated sentences that seem to, in their minds, support their opinion. Yet they miss the overall concept the paper is putting out. This is a classic example of that. George Musser, in that same article and in the interview with Fight the Flat Earth, also famously said that gravity is not a force, but you can think of it as a force. And that's a very clear statement. Gravity technically is an interaction between mass and space-time. However, it behaves, especially in our macroscopic world, exactly like a force. And you can treat it as a force to try and determine the trajectory of bullets or how to build a bridge. That was the entire point of the article. And it completely went over QE's head because he is a literalist. So let's go ahead and continue.
The next one is from Caltech. Einstein came up with the theory of general relativity in 1915, the prototype of all modern gravitational theories. Its crucial ingredient involving colossal intellectual jump is the concept of gravitation, not as a force, but as a manifestation of the curvature of space-time. So let's take a look. We'll do a keyword here. It saves an enormous amount of time. Just be patient with me. Let's go paste. Okay, okay, here we go. The prototype of all modern gravitational theories. Its crucial ingredient involving colossal jump is the concept of gravitation, not as a force. So this is my citation, right? We're going down to 2 paragraphs from that. Okay, what we're looking for here, again, is some atomic and atomic particles, the speed of sound, and Einstein reverting to Newton. So let's go with, let's see if we can find these Einstein field equations, Newton, in which a body of previous G, constants G, is Newton even mentioned in here? No. Some atomic particles? No. The speed of sound? Oh, there's Newton. Einstein also replaced the Newtonian law of motion by the statement that free test particles move along geodesics. I want to spend some more time here, not today, but Bubby, it says nothing. Oh, and this constant G, this G, big G, doesn't occur in Newton's universal law of gravitation, by the way. So you're 0 for 2 here.
Or am I, Quantum Racer? Let's go ahead and have a look. So here's your citation right here, this paragraph. And I agree with this completely. Then you go 1, 2 paragraphs, and you look for what I was talking about. And that is that unless you are approaching the speed of light, you're dealing with very massive or very tiny particles. Newtonian physics works just fine. You know, in our everyday world, we live in a Newtonian world. That's how we fire rifles. That's how we build bridges. You think that you have a little bit of a triumph because 1, 2 paragraphs down from your quote, it doesn't directly contradict you. But then again, here is the page that you're putting up. Let's look at the very next paragraph. Despite the great contrast between general relativity and Newtonian theorem, the predictions of the former approach the latter for systems in which velocities are small compared to c, the speed of light, and potentials are weak enough that they cannot cause larger velocities. This is why we can discuss with Newtonian theory the structure of the Earth and planets, stars, and stellar clusters, features of motion in the solar system without fear of error. In other words, exactly what I said. Einsteinian theory, or reduces to Newtonian theory, unless you're dealing in very specific circumstances, such as extremely massive objects or extremely fast objects. Now, by the way, just to clear something up for you, since you made a big deal about the fact that Newton's law of universal gravity does not contain G. G is what's called a constant of proportionality. Newton's universal law of gravity was a proportion, and that is that force was related to mass 1 times mass 2 over the radius squared. The fact that it doesn't say equals means that there is some sort of constant of proportionality in front of it. That constant of proportionality is called G. That allows us to say the gravitational force is this, rather than it is related to this. It gives us a quantitative versus a qualitative number for the force. So let's see if you can overcome this. Now, your first article was unrelated to the actual question. This article directly contradicts you. So let's see how you do on the next one.
The next one is Brian Cox. This is a YouTube video. It's not a paper, so we can't go 2 paragraphs because there isn't a second paragraph.
Then we're going to go ahead and skip it, and we're going to go to the next one.
The next one is Wikipedia. Let's go with 1915 here. Gravity is most accurately described by general theory of relativity proposed by Albert Einstein, which describes gravity not as a force. So let's go to their alma mater. Let's go ahead and find, is that the same one? Oh, yeah, it is. Okay. So gravity is here's my citation. Let's go 2 paragraphs. It's this. Now remember what we're looking for. We're looking for Einstein reverting to Newton, subatomic atomic particles, and the speed of sound. Got quantum, no Newton, no speed of sound, no subatomic or atomic particles. Bubby, you're operating over.
Now, once again, this is cherry picking. So for example, he's citing this paragraph right here, and then he's going down 1, 2 paragraphs to see whether or not something is said about my premise that unless you are dealing with very massive objects or objects moving at close to the speed of light, Newtonian physics and Newtonian gravity works very well in our macroscopic world. So that's the second paragraph, and it doesn't really talk about it. It's getting into quantum mechanics, etc. Look at the paragraph directly above it. It's talking about the weakest of 4 fundamental interactions. I learned these in school as the 4 fundamental forces of the universe. You have strong and weak nuclear forces, you have electromagnetic force, and you have the force of gravity. They're calling them fundamental interactions here. They just changed the words on it. That's fine. But look what it actually says. In contrast, it is the dominant interaction at the macroscopic scale, and is the cause of the formation, shape, and trajectory of astronomical bodies. For example, gravity causes the Earth and other planets to orbit the Sun. It also causes the Moon to orbit the Earth, and causes the formation of tides, and the formation and evolution of the solar system, stars, and galaxies. We're going to have to chalk that one up to me as well. It was the first paragraph after his quote. And again, on the page that he is holding up as an example of how I am wrong, yet it absolutely agrees with me. So, you're 0 for 3 there, QE.
In general relativity, gravity is not a force between masses. Let's go ahead, we'll use this one. Universe today. Thanks for your patience. That's not it. This is it. Okay. In general relativity, gravity is not a force between masses. This is my citation. 2 paragraphs down. Remember what we're looking for. Subatomic, atomic particles, speed of sound, or Newton. Oh, it says Newton. Einstein agreed with the amount of deflection agreed with Einstein and not Newton, so nothing in the context you were talking about. No subatomic particles, no speed of sound. Over. Oh, and by the way, I've been charged with changing this citation. For some reason, somebody said this, and I think, you know how they all work? They all gravitate, no pun intended, and they all just parrot this stuff. Oh, QE has modified this citation right here. Really? In general relativity, gravity is not a force between masses, right? That's what I said. Let's go back and check. In general relativity, gravity is not a force between... What did I do to this? Nothing. It's good. It's just like how it was written.
Okay, this one actually needs to have the article pulled up. Let me go ahead and do that real quick. Now I'm going to go ahead and address the misquote first. He sees exactly what I told him he was misquoting, immediately tries to blow it off and get past it and get it off the screen as quickly as possible, and then goes to a different section. Watch him dance.
Thanks for your patience.
All right, I want you to stop right here. Now here's the important thing. How we know gravity is not just a force. What exactly does that mean? Now, is gravity a force? Technically, no. it's more than a force. It's the bending and warping of space-time and geodesics and field equations. All right, there's a lot of other things that go on with gravity. We've always looked at it traditionally as a force, and we use it as a force, but it's actually much more than that. That's the entire thrust of this article. Now, QE sees this and realizes that this is a major problem for him because he left out the just. So let's go ahead and watch how he dances around it.
That's not it. This is it. Okay.
Okay, so you see, he didn't want to address that at all. But he will come back and say that I misquoted him when I said he left out a key concept of the phrase here. Now, the example that I used in the original video that he's referring to, you can take a phrase and selectively remove words from it. So, for example, if you were to hear a phrase that somebody said, QE is not a liar, that has a very clear meaning to you. But if you go to the original source and find out what that person actually said was that QE is not just a liar, he's a fraud as well. That has a very different connotation. That is the change that he made. Now, I've gone ahead and pulled up this article. Once again, QE is trying to misrepresent the entire meaning of the article. Again, what is the very first sentence? How we know gravity is not just a force. Now, the very first paragraph goes on to say the way we think of gravity is as a force, because it acts like a force. As George Musser put it, gravity is not a force, but you can think of it as a force. There's a lot of wisdom in that word, and it's a very clear understanding to anybody that wants to take the time to even think about it for a fraction of a second. Now, gravity does exert a force on masses, and that's what we weigh on our bathroom scales. However, the article goes on to talk about gravity being a much more complex phenomenon than simply a force. It's the warping of space-time in response to the presence of mass. And it talks about several different concepts that demonstrate that. For example, the equivalence principle, the bending of light from the solar eclipse observed by Arthur Eddington in 1919. This is the first true confirmation of Einstein's theory of relativity. Most notably, it says that Newton and Einstein both predicted the light would be bent, but Einstein said that it would be bent a little bit more than Newton did, and that turned out to be exactly the case. There's changes in time based on speed. There are gravitational waves. There's frame dragging with GPS satellites. These are relativistic concerns of a Newtonian system. So basically, that's what this article is discussing. It's not simply a force between masses. Gravity is instead an effect of space and time. I think that's really quite clear. We look at it as a force, but it's actually much more than that when you look at these examples. And again, although we live in a Newtonian world, there are examples where Einstein describes the effects of gravity better than Newton does. And again, that's my point. I can't give you this one, QE, but since you're the type of person that writes and grades your own tests, I'm sure you'll get an A on your interpretation of this.
So I don't know what the heck you guys are talking about. From MSU Making Shit Up University. And by the way, Booby, you're still over, by the way. So, this is a good one. Strictly, that'll stand out. Paste. There we go. Strictly speaking, gravity is not a force in general relativity, right? That's my citation. So, guess what we're going to do? Like Bob said, Bubby, we're going 2 paragraphs down. Okay, remember what we're looking for. Subatomic and atomic particles, speed of sound, or Einstein reverting to Newton. So there's nothing in here on Newton. I don't see subatomic or atomic particles or the speed of sound. Still over there, Bobby.
Now, to make this a little easier to read, I'm going to go ahead and pull this up in its original form. And that's it right here. Now, again, let's go ahead and find his quotation, and that is right there. Gravity is not a force. Now, we didn't need to go down 2 paragraphs in this one because it's contained 1 sentence over right here. For weak fields, translation QE, that means non-massive objects and not subatomic particles. For weak fields, one could describe the theory in a sort of Newtonian language. In that case, one finds the force in general relativity is not quite central. It does not point directly towards the point source of the gravitational field and depends on velocity as well as position. The net result is that the effect of the propagation delay is almost exactly canceled, and general relativity, pay attention QE, very nearly reproduces the Newtonian result. So you had your butt handed to you on that one as well, QE. You know, you didn't even have to go down 2 paragraphs. It was in the very paragraph that you cited as support of your silly little theory. Well, I don't know about you guys, but I'm starting to have some fun with this idiot. So let's go ahead and let him continue and have him dig his hole a little deeper.
Let's go to physics.org or Physicsorg. See what they got here. It's not looking too good for you, Bobby. According to this theory, gravity is not a force. There you go. That's my citation. So we'll go down 2 paragraphs, like you said. Remember what we're looking for: subatomic and atomic particles, the speed of sound, or Einstein reverting to Newton. So for most applicant gravity, okay. Gravity is best explained by Newton's law of universal gravitation. Okay, we're going to come back to that. Hold on 1 second. I want to make sure the speed of sound and no subatomic particles. We're good. Okay. First of all, this doesn't have any context with what you claimed. And gravity is best explained by a law? Whoa. Laws don't explain. They describe. That's a big problem.
Well, here we are, 2 paragraphs down from his quote, and again, his source contradicts him. So what's he do? He tries to segue over and do a little dance by playing the definition game. QE had your butt handed to you again on this one. You need to start reading the citations that you use, because if you don't, you will find out very quickly that they didn't say what you thought they said. And this is a good example of it.
Let's take a look up here. General theory of relativity, which remains the best means of describing. You see, people, scientific theories explain. They don't describe. Laws describe, they don't explain. So how can this be the best means of describing and Newton's law be the best means of explaining?
He doesn't even know when he's been beat, does he? Oh well. You know, that is an underlying problem in the flat earth, and that is that they cannot admit when they're shown to be wrong. They just can't admit it because their entire sense of identity is so tied into this flat earth fantasy that they have. It's sad in a way. Get some help, QE.
All right, let's go with PhysicsLibraText. Let's use answer. Yeah, that should do it. Copy. Let's check this one. What are the chances you're going to be right out of the last 2? You know, to support your claim. So here it is. Yep. The answer is that gravitation is not a force between 2 objects. That's my citation. So 2 paragraphs down. Remember, subatomic and atomic particles, speed of sound, or Einstein reverting to Newton. I'm looking for Newton. No Newton. No subatomic particles. And no speed of sound.
Okay, so let's go ahead and have a look at the actual citation. Now, you may have noticed that he rushed over this, which is PhysicsLibraText. Okay? We'll read right here. Newton's law of universal gravitation accurately predicts much of what we see within our solar system. Indeed, only Newton's laws have been needed to accurately send every space vehicle on its journey. The paths of Earth-crossing asteroids and most other celestial bodies can be accurately determined solely with the use of Newton's law. Then it goes on to say that there are certain phenomena, such as the bending of light around massive objects or the orbit of Mercury, do expose some weaknesses of Newtonian universal gravity. For the meaning of this paragraph is quite clear, and that is that Newtonian's universal gravity works great in everyday situations, exactly as I was discussing. There are exceptions to it in special circumstances that are better explained by Einsteinian relativity. But for our day-to-day life, Newtonian physics works just great. And again, that's from QE's own source. That actually is one of the lead paragraphs of this section rather than a paragraph following his cherry-picked citation. So things aren't looking good for you there, QE.
Bubby, last chance. All right, Hyperphysics Textbook. Sorry this is taking so long, folks, but I must do this. Hold their feet to the fire. This is my citation. He said 2 paragraphs down. I don't treat that. That's not a paragraph. That's not a paragraph. That's a paragraph, but that's connected to that. This is 2 paragraphs down. So let's see what we got here. Any subatomic or atomic particles, speed of sound, or Newton reverting to or Newton, Einstein reverting to Newton? No, nothing, 0. Nothing in here either. Let's just keep on going down just to make sure. Nope. 0. They're talking about the cosmological constant.
Now, this final section that he talks about is looks like a chapter out of an online textbook on physics concerning general relativity and only general relativity. This is not a source I've seen him use in the past, and it's not one that I've addressed. This does not address the everyday world as far as the ability to use Newtonian physics in the everyday world, as we've shown in almost all of the other citations that he used, some of which rather dramatically. So, unless he can discuss these particular equations and the concepts behind these equations, he really doesn't have anything to talk about other than to say he had his little buzzword in it. So the bottom line is this. My statement was very clear, and that is, in the everyday world, as long as you are not dealing with massive objects or objects moving close to the speed of light or very tiny objects, Newtonian physics works very well for everyday work, everyday engineering, everyday putting satellites into orbit. The very fact that you are arguing for Einsteinian gravity, which mandates space-time, which mandates gravity, which mandates objects in orbit in space around other objects, which basically mandates a spherical Earth. You just show that you are trying to find certain buzzwords, QE, without having any context of the meaning or the implication of those buzzwords. So, this is Bob the Science Guy signing out from Northern Michigan. Once again, it's always a pleasure to eat your lunch, QE. You take care, and remember, every time you put up a citation, there's a reason you won't actually link the citation to it. It's because you're afraid people will actually look at it and find out how full of shit you are. So, take care, everyone. Thanks for stopping by. Remember to like and subscribe to my channel, and I'll see you again soon. Our next episode is going to be on the transit of Venus and determining the distance to the sun and stars. So take care, my friends.
Mama, please make them heavy, or I can't teach them anymore. This rabbit hole's too deep for me.